A volcano is a mountain or large hill containing a conduit that extends down into the upper mantle, through which magma, ash, and gases are periodically ejected onto the surface of the earth or into the atmosphere. Deep in the earth, it is very hot. It is so hot that rocks melt. The melted rock is called magma. The magma is lighter than the rocks around it, so it rises. Sometimes it finds a crack or a hole in the earth's crust and bursts through. This is how a volcano begins. Pressure builds deep in the earth where the magma is. Suddenly, the gases escape and violently explode. It is kind of like toothpaste squirting out of a tube when you give it a hard squeeze. Volcanic dust is less than 0.25 mm in diameter. Volcanic ash is more than 0.25 but less than 5 mm in size. It's almost equal to 1 grain of rice. Cinders are volcanic bombs the size of a golf ball. Volcanic bombs few centimeters to several meters. Volcanoes do not all look alike. Their shape is based on what type of materials they erupt. There are 4 main kinds or shapes of volcanoes. Number 1, fissure volcano. Number 2, shield volcano. Number 3, cinder cone volcanoes. And number 4, composite or stratovolcanoes. Fissure volcano is a linear volcanic vent through which lava erupts, usually without any explosive activity. The vent is often a few meters wide and may be many kilometers long. A very broad volcano with shallow slopes that forms an association with non-viscous lava flows would be a shield volcano. This kind of volcano is low and broad with gently sloping sides that surrounds a central magma chamber. They look like a warrior's shield. Magma associated with shield volcanoes typically has low viscosity, which allows it to flow freely in broad streams of molten lava. Cinder cone volcanoes form when solid rock and ash shoot up into the air and fall back around the volcano opening. The cinder cone volcano has steep sloped sides almost at 30 degrees angle, which usually forms very quickly after a single eruption. These volcanoes are small relative to other types of volcanoes and consists of solidified magma fragments, rock debris, and ash that are ejected from a central vent. Composite volcanoes erupt with molten lava, solid rock, and ash. The layers pile up much like layers of cake and frosting. The layers form into symmetrical cones. Composite volcanoes are typically inactive for long periods of time between eruptions, but when they do erupt, they tend to do so quite violently. Also called stratovolcanoes because they contain strata or layers of volcanic debris. These volcanoes typically have moderately steep cones with a semi-horizontal top containing the crater. Mount St. Helens is an active stratovolcano located in United States. It is most notorious for one of its major eruptions, the deadliest and the most economically destructive volcanic event in the US history. In the given picture, please have a look at the near-perfect conical shape of Mount St. Helens before the 1980s eruption. The catastrophic eruption happened on May 18, 1980. The picture is of the same Mount St. Helens after the eruption. The blast was so explosive that much of the peak was blown off, reducing the height of the mountain from 2,950 meters to about 2,550 meters and leaving a wide crater. Note the lava dome in the center of the crater. Now let's talk about some volcanic terminology. The first one is crater. Now, a crater is a funnel-shaped pit or depression which you can see at the top of the volcano. A caldera is a volcanic feature formed by the collapse of a volcano into itself, making it a large special form of volcanic crater. A caldera collapse is usually triggered by the emptying of the magma chamber beneath the volcano as a result of a large volcanic eruption. Let's talk about some of the differences between caldera and crater. A caldera looks like a volcanic crater, but it is actually formed when the overlying rocks collapse when a magma chamber is emptied, creating vacuum below. A volcanic crater is a bowl-like structure at the top of a volcano that has the opening for the eruption of lava and the ashes. Thus, a caldera is a special type of crater. A crater is formed by sinking of the top of the volcano as lava weakens the rocks. On the other hand, a caldera is formed when the overlying rocks collapse to fill an emptied huge chamber of magma. When a caldera gets filled with water after some time of its formation, it is called a crater lake. A lava dome is a steep-sided volcanic landform consisting of highly viscous lava that does not flow far from its point of origin before it solidifies. An active volcano is the one that erupts fairly regularly. A sleeping volcano with no signs of any activity is considered to be dormant. A volcano which has not erupted in the past 10,000 years is often listed as extinct. The extinct volcano no longer has a lava supply. An extinct volcano is no longer near an active geologic hotspot if it ever was. Volcanologists sometimes can't tell whether a volcano is extinct or dormant. There are many examples of extinct volcanoes. Ben Nevis, the tallest mountain in the United Kingdom. Hawaiian Emperor Seamount chain in the North Pacific Ocean. Huascaran in Peru. Keshu Palau Ridge in the Philippine Sea. Mount Buninyong in Victoria, Australia. The Nut in Tasmania, Australia. Tamu Massif in the Northwest Pacific Ocean. Wav and Nemu in Libya. Edinburgh Castle in Scotland is located on a dolerite plug, the remnant of a volcano that went extinct many million of years ago. Now let's talk about volcanic zones. There are three main places or zones where volcanoes originate. Number 1, hotspots. Number 2, divergent plate boundaries such as rifts and mid-oceanic ridges. And number 3, convergent plate boundaries such as subduction zones. The origin of the magma for hotspots is not well known. At a divergent margin, two tectonic plates are moving apart, and the magma that is generated in the upper mantle flows upward to fill in the space. This magma is probably generated at depths that are shallower than those for hotspot magmas. People argue about whether the magma forcing its way to the surface causes the plates to move apart, or whether the plates move apart and the magma just reacts to that and fills in the space. Perhaps it is a combination of these two. The most extensive example of this type of volcanism is the system of mid-oceanic ridges. Continental examples include the East African Rift, the West Antarctic Rift, and the Basin and Range Province in the southwestern US. The final major place where volcanism originates is at convergent margins, that is subduction zones, where an oceanic plate dives under either another oceanic plate or perhaps a continental plate. As the plate gets pushed further and further, it starts to give off its volatiles, mostly water, and these migrate upward into the mantle just under the overriding plate. The addition of these volatiles to this overriding mantle probably lowers the melting point of that mantle so that magma is generated. Part of the magma may also be generated by the downgoing plate actually starting to melt as it gets into the hotter and hotter interior.